Okay, perfect. We are live. Welcome back to this episode of Flashwares. This is episode 5. Today we have Mateusz and dmarz who will host a session, and Ferran as well, excuse me, who will host a session on the unique features that TEs enable for MEV applications. Additional information can, as always, be found on the forum for this session and any upcoming sessions. So head over to collective.flashbots.net. If you have any questions, that's also where you can post them after the session. Otherwise, feel free to post them in the side chat. And with that, I'll hand it over to you guys.
All right. So as usual, we have not planned anything. This is let's just do it live, right? All right.
Doing it live.
Hello, dmarz.
What's up? How's it going?
Okay, let's jump right into it. I have hopefully my screen sharing is working. All right. I want us to draw some stuff. How about let me share. Let me share the link. If you're watching on YouTube, yes, you can edit this if you want to. Yeah.
Okay, right. Sweet. I'm in there.
Let's go. Okay, so dmarz, how I would like us maybe to start is by you describing a example application that you'd want to put in a T, and let's see what useful features can provide.
Okay, sweet. I think there's quite a few we could do, so maybe I'll list some options. I think the simplest example would be something like MEV share, so an order flow auction, where we have a user who submits a transaction or an intent. Some piece of information is leaked to the outside world, and then sort of a transaction is sent back, packaged up and sent to the builder. Another example we could do is something like a dark pool. So that would maybe be, I send in an intent, something is constantly, running what's essentially a non-lit order book and is trying to match me against other intents. Someone then finally sends in another intent, they get matched, packaged into a transaction, and then shipped to a block builder. What else could we do? I mean, for a while I worked on a sealed bid NFT auction protocol, which did like off-chain ordering. I think that's like pretty fun. And then, yeah, I don't know, something with AI. That's my fourth one. What do we think of those?
All right. Yeah, we'll probably have. So we have booked 2 hours for this, so we have probably enough time to go through basically all of them in any order. I'll probably go with maybe the dark pool first.
Ooh, that's the fun one.
I think that's the fun one, right? And then we can think a bit longer about what else. Like maybe we could do an AI thing because it's going to be short and it's going to be different. Because I'm sure it will be very similar to the dark pool, right? And
yes.
Yeah, and the sealed bid protocol should probably just be a swap, right, on the swap chain. But yeah, we'll see. We'll get into it and see why would we put it like natively on a T rather than have it live in Solidity.
Totally.
All right. So walk me through the dark pool and let's see how well I can draw this.
Okay, sweet. And we're making this up live, so
yeah.
Let's go through it. I mean, so let's start with the inputs and the outputs. Inputs are EIP 712 signed to messages. We can call them intents. We should ideally have a ton of intents. It's like, you know, the is the requirement. Just so we can think through yeah, like what type of scale this actually needs to operate on. Not that we're gonna, you know, POC anything at scale today. Yeah, how many? Let's see. I'm trying to find how many swaps CowSwap does an hour, but I cannot find their Explorer. Okay. It is not easy to see how many swaps are happening. Oh, okay. I can look at their settlement contract. It looks like they're going for 1 a block, roughly. So
1 a block, all right. So what goes out is 1 a block. Okay. So. Okay. And so we have users. And we have some kind of LPs, right? What are they usually called? They're not solvers, right? This is the solver free, you know. I guess there's smaller, I guess there's less of them and they're like bigger.
They're huge and we don't know who they are.
Yeah, anonymous LPs. All right, and they also submit to the order book, right? It's like the same.
All right, we have from the chat, please restrict to value transfer intents.
That's not much of an intent, chat.
What is the definition of a value transfer intent? Does that mean we're just not swapping something?
All right, let's wait for a clarification and continue. So we have.
What if chat? If I send a hug to Mateusz over an intent, is that a value transfer intent? Okay.
All right. So I have some order book, and LPs probably look exactly the same as users, right? It's just that they're matching from the other side. Okay, I would guess. So it's all just EIP 712 intents.
Yep. Yeah, I think they would probably, I think there's quite a large design space here on what the user actually, so what the user sends in and then also what the LPs send in. But we can keep it simple for now.
Yeah, let's keep it simple. All right, so we have this. We have an order book, so let's call this the T box, right? Okay, let's not call it the kettle. Let's call it a T app. Right. So if we are designing this app as like okay, what else? There's something else here, right? There's like a matching engine or something, right?
Yep, exactly. Something that basically just needs to like poll or have a loop that it's constantly trying to match on.
Right.
And then we probably need like a batch submitter or something like that.
Okay, yeah, because the output of the matching engine is some stuff which isn't immediately useful, right?
Yeah.
It's just like a chain. Yeah, batch submitter.
Which funny enough, a batch submitter is exactly also how L2 OP stack L2s work. They create the block and then send it to the batch submitter.
Let's go. Okay, so this is what goes here is the solution, right?
Yep.
So matched intents. All right. So the matching engine basically just requests orders from the order book, right? I think that's kind of all it gets, and then there's probably like a notification going on. Right. So notify whenever new orders come around, and you get me the orders. And what goes here is like a signed TX, right? All right.
Yep, exactly.
And this goes.
And then it probably goes to a block builder,
yeah,
which should also be another T app.
All right, cool. So that's the app, right? There's some moving pieces here, right? It's not very simple.
Yes, I would say also, I believe it needs some access to live, live data from whatever the settlement layer is. Let's just call it an L1. This way, you can actually verify if the intents are still valid or not, and if any have gone through.
Right. Yeah.
Any considerations we're missing, chat, please let us know.
All right. Okay, let's not this go. All right, we have some data going from the outside. Yeah, that you're right. This is very important. Okay, but it goes in, right? So it's not as bad. Okay, so change state in. Okay, so we have inputs. We have the state, right? And we have the outputs. All right. Okay, so inputs we already know. This is simple. So this is inputs. And then we have the change state. It can be a P2P or just an endpoint, right? Or like a state diffs. And it's kind of it, right?
Yes.
So on the internal state, we also have the change state, right? We keep up with the chain locally, probably, some way. Then we need a signing key for the batch, right?
Yes.
Or do we just output, or do we just output the 712 messages and call it done? Yeah.
Well, we'd still need a key for the messages, right?
Yeah. Account abstraction. Can we have a paymaster for this and not use and just randomly generate a key?
That would be cool for sure.
Yeah, but we need some key. And yeah, but if we randomly generate it, it doesn't matter, I guess. Yeah, a paymaster would be nice. Yeah, but okay, let's also look at the case where we want like a T, like the T key. All right, and then here we have just the batch. All right. So what do we want? Okay, so if we are designing this as an application, forget T's, right? How would we do this? How would this look like? So we would probably have some API here, right? some endpoint, let's think for a sec.
Okay. I was emojifying, sorry.
Yeah, good touch. Okay. Okay, I don't think there's anything out of the ordinary here. So we just want like an API server, right? So a place that you can submit 12 signed messages, right?
Yep. Probably just 2 routes, some type of admin routes, maybe.
Some type of admin route. Yeah, if we do this as a normal service, we probably would have a separate admin API, right? Like,
yeah, that's right.
Yeah, like admin. Or like, an admin console, like whatever. It doesn't have to be a socket, but yeah, but here we have, some endpoint. There's like actual URL that people would submit to, right? And here is probably like console. Console like input to the API. It's local only. Oops.
At Partha, Andrew's saying, I think the assets need to be escrowed with the T for exclusiveness.
The assets.
Okay. We have those 2.
All right. And then we have just, I'm kind of redrawing this, but maybe it will be helpful. So we have an order book service internally, right? Like imagine this being like either a separate, like a container or something like that, or maybe a part of a bigger app, right? We can draw a box here and call it a slightly bigger app. Okay, so we have the order book and we have the matching, the engine. Right. And then, okay, and then now I think this is where it becomes kind of interesting, right? Because now we need the key, right? Where do we store the key? Right. We have the key somewhere here, and it's probably like, goes like this, right? Because this key needs like funds on it. It cannot be like just randomly generated. If like, at least if we're designing a regular app, this would be like, some kind of threshold key, I guess, or something like that. It goes from the outside anyway.
I think, yeah, if this was a regular app, we'd be reading this key in probably through an environment variable, right? And potentially is threshold. Yeah, no, threshold makes sense. Because users would likely need to approve to this key. So if the key is compromised, that would be very bad. Therefore, we need multiple tiers of security behind this key.
Yeah, like CowSwap, does CowSwap sign their patches, right?
I believe that's a good question. I actually believe how it works in CowSwap is that the solver is allowed to submit the batch.
Yeah, so it's the solvers that signed. Yeah, makes sense. And they just pick the best one, right?
Yes, but solvers, yeah, exactly. So solvers need to be staked, and then I believe they're allowed to submit a signed transaction solution. That's a bit cleaner. But of course, it leads to the scenario where you need to like police in case they accidentally send a solution which isn't correct.
Yeah. So this also would work almost exactly like a CowSwap solver, right?
I think it would look quite similar to a CowSwap solver, yeah.
Right. So we have the private key in. This is the relevant part. Here we have the orders, of course. Intents. Yes. And here also intents. And here we would just run like a full node, right? Right, we wouldn't be bothered to just run, the chain nodes.
Yeah, I think there would be some type of validation as well before the intent gets put in the order book service. Which, like, I think if we wanted to go fast, would be some type of like cache with what the user's nonce is and their latest ETH balance. And then maybe also the asset, seeing if they've approved any of the ERC20s that this dark pool supports.
I see. Okay, so this goes into validation. Okay, I'm messing up my arrows here. Okay, intents go into validation. Then to the order book service, right? So there's some kind of like in memory, like it's a database or whatever. I guess we can add a database here. Let's get the database. All right, so let's get the key. A modification to it. Okay, and then the submitter signs. And then the signed transaction goes out. My chain node doesn't fit.
Ooh, interesting comments in the chat. Are solvers just decentralized brokers? Only if they use their own inventory.
Are they decentralized?
Yes, chat. Are they decentralized even in that case?
Like even here, we are not decentralizing the solvers. I mean the piece, and you'd probably usually think of them as the solvers. Yeah, this would be a decentralized solver, I guess. And not using their own stuff, right?
Yes.
Okay, so that's kind of it, right? That's kind of what we how we would structure this if we were to do this, ignoring privacy and decentralization, right? So
yes.
What's the important bits that we can provide as what's the bits that would allow us to make it decentralized and fully private, right? First of all, can this key be known outside of the service? Probably.
Known as in the pub key or the private key?
Yeah, like is it important that nobody has access to the private key?
I think likely
Right?
yes.
Like if you go and run this, like you just need a key with funds, right? It actually doesn't matter whose key it is.
The Yes, I would definitely be interested in hearing from the chat on this, because I think we've got some chain abstraction people on this. But I think the main issue is that you need to deposit the intents into a settlement contract. The settlement contract needs to be approved by the user to transfer their funds. That's one route. The other route is the users just transfer their funds ahead of time to a key that this controls, which is probably more dangerous.
Yeah, let's not go there. Okay. So the users, okay, so the worry here is that if the key is known elsewhere, then someone with access to the key could do something that the users don't want.
Correct.
Because you approve the key, right? Like you could be matched against something that doesn't make any sense, for example.
Yes. Yeah, I think that's correct. Well, yeah, no, I think it is correct. I think there's no way around it. The only way around it is to unfortunately leak your data. To like leak your, the validity condition around your intent.
Yeah, actually, because like we will not. Yeah, so the thing is, because we will batch it, right? So you will not learn the intent. Like even if you have access to the key, you will not learn the intent before it's submitted as a batch, right? But at that point, you can still try to submit a second batch, right? That abuses the user in some way, right?
Yes.
So, because in some cases this will actually help you because the intents, even though you could, screw the user over, you actually don't have the access to the data, right? So if the builder was also in a T, right, like in this case, this actually wouldn't matter because nobody learns the data, right, before it's like a part of the chain. I guess you can still like argue about forking out the block, and uncles do happen. But you can also worry about like if this is an L2, you can worry about someone trying to go through L1, or I don't know if that would be a concern. Okay, anyway, so we want a key, right? That's that only the T, only the T knows. Right, and then the users can be sure that the only way they will be matched, and the only way they'll be a part of the chain is if the specific key is signed there, the solution, right, to the batch. All right, so we probably also want, guess what else do we want? So there's the chain now. There's the chain, right? It's the chain state, and there's the like some kind of data storage, right?
Yep.
So doing anything specific, can it be ephemeral? Like I think it can, right? It's,
So I think it depends on the type of intent. I think if this service was focused on intents that resolve in the next couple of blocks, then you're probably not that mad if, say, there's a restart and your intent is lost. If you are doing some type of passive intent, which could take days to clear or something like that, then you would definitely want it to persist past a restart. And actually, you would want to be notified that your intent is, or not even notified. I think it would be good to be able to query if your intent is still in there in a way that doesn't leak the data. So perhaps just a Boolean of whether your intent hash is in there.
All right. So like check if still right, some kind of like an endpoint where we want to check.
Yeah, Partha in the chat brings up cross-chain order matching will require caching. I think let's stick with one chain for now, but that makes it more fun for sure.
So cross-chain matching would require a caching. What is that?
I think that's just having multiple chains state cached up.
Oh yeah, but that's simple, right? Because what you do is you just right, do more of those chain nodes, and now your service has to handle more than one chain.
Totally.
Because that's it. Like we're not trying to make this atomic, right? This is not like going to be atomic cross-chain stuff. Yeah, so yeah, cross-chain intents will for sure require some additional care, but I don't think there's anything specific that they would need. That's not here.
Totally.
All right. So, but for like passive stuff or passive intents for like LPs, right? We want persistence.
Sure.
Across restarts and ideally censorship resistant, right?
Censorship resistance.
Because if you restart your server and then if whoever controls the hardware is able to wipe out the state, right? Then they can like forcefully empty the order book, right?
Yeah. I also think that brings up an interesting point of like, I'll take some notes down here of like the ret model, right? Like basically we can have users. Okay, so user submitting intent, LP submitting intent, and then also hardware operator. Or is this or T operator maybe? I think that's probably like one of the biggest mindset shifts in building on a TE is, obviously with traditional off-chain services, you're just sort of entering in a social contract with your users that you won't abuse. You won't abuse their data, but the T sort of like absolves a bit your responsibility there. You're sort of saying like, hey, it's on this trusted hardware. You don't have to trust me. But if they leave in sneaky backdoors, there is still, or not even sneaky backdoors. It's more just things outside of the controlled box we have created that they can use to alter the outcomes of the app.
Yeah, and this here is super relevant, right? Because if you expect that there's like an order coming and you want to match it, right? You can forcefully like remove everything and then only put your own, and then cut the network connection and make sure that you're the only order in the order book.
Totally.
So I think you're right. This is a big difference. And also, so this comes in two parts. One, because there's no, there doesn't have to be an expectation that the operator is not malicious, right? You can assume they are malicious, and the app should still withstand, right, a malicious operator. But what that gives you is that anyone can run it now, right? Because the app allows for a malicious operator, right? And that's the big difference, because now you can decentralize this, right? That's how you can actually decentralize those services.
For sure.
Yeah, but it does require some very specific solutions like censorship resistance, persistent, persistent storage, right?
Yeah, it also makes me realize, so one other thing too is these intents should probably be encrypted to the key on the machine. Which if they're,
you can reuse the same key.
yes, you can. Is it a
Yeah,
good
just
idea to
derive a
reuse the
second
same
one, of
key?
course.
No,
No,
okay.
but like you could in theory, right?
Yes, and just to clarify for those listening, like the attack vector would basically be you open up a port on this TE, but then you open up another proxy server, which you tell users about, and you run some code there, which, anytime someone's trading USDC for like Rooster coin, I could, delay it, insert my own before to front run, and then reinsert it. So that way encryption would block this.
Yeah, it's like a man in the middle, pretty much.
Yes, man in the middle for sure.
Yeah, so we want the users to be certain that their intents will only go to the box, right, into the T.
Is it possible also to give a front end some type of assurance that they actually talked with the T, or is that out of scope right now?
An assurance to the user through the front end?
Yeah. Like, can we get some type of like attestation on the front end?
Yeah, as long as it's just the front end that works, right?
Mm.
Because we can prove it to the front end, and then the front end like cannot prove it to the user, right? Because it's just a bunch of code. But if the user knows what code is running in the front end, for example, because they just deployed it, then they can be convinced that it's correct.
Right. So we need I think we need to add a new browser into the scope of this as well. Just kidding.
Yeah, I think that's simple, because if you you just need someone other than the operator to be able to verify the correctness of the setup, right? And then whether it's the user directly or whether it's a front end, they kind of check it in the same way, right?
Totally.
So you only need to do this once, I think. It would be nice as a kind of framework feature, right? That if you want to put it on your front end, this is the library for it, right?
Mm-hmm. Also, everyone should download their front ends off IPFS. It's the only safe way.
Please don't put your private keys into the browser. And don't sign the IP712 messages. This is your front end. All right. So how do we convince the users that their intent goes only into this T app and not anywhere else? The simplest solution would be to use what's called array-TLS. Right? It's linked in the forum post for anyone wondering. It's like a paper from Microsoft and also like a technical solution. How it works is it leverages like the TLS certificate, and it puts parts of the attestation report, like the attestation report, into the TLS certificate that you can then check. Right? It's like extra fields that you can parse. So it's gonna use like a locally generated random key, which is also good. So it's similar to how we could handle the signing key, where we just generate it inside the T, right, and make sure that the code never lets it out of the T. That's how we can be convinced that that the key is only accessible inside the T, right? Nobody passes it in like here, like in the centralized server. Rather, it's generated inside. So okay, let's redraw this as a T swap, and then it should become obvious what should be the features that we want to provide the users. All right.
Also, one note is that we didn't handle making this application distributed yet, but potentially.
Yeah, but so it's at least decentralized. Like this is neither decentralizable nor distributed, right?
Right.
This here you can decentralize. It like doesn't require anything central, right? So it's like decentralized by nature. Anyone can run it, and as long as you check the attestation, as long as you're convinced that your intent is gonna be safe, you can send it in, right? Which is not the case in the centralized server. It's not like you would be forwarding to anyone.
Right. But I think if we wanted to make it like truly distributed, you would need to sync like order book services across different instances, right? But I think that opens up a much more to design.
It's a kind of worms, right?
Yes.
So how we can solve this almost trivially, I think, is you could put a box here that forwards to like just multiplexes. So if the user wants to send their intent into multiple order books, then they'll just be multiplexed, and that's like 50% of the way. It's a different story with the sources, because in a decentralized system, you also want the best solution to win, right? Rather than like in whatever notion of best would be for that. Right? Like for a specific user, the best price they can get, right? So you'd want each user to you'd want to maximize some sort of function with the solution, right? And then you'd also want to, if the order book is not fully in sync, you'd then want to sync on what's the best solution and what should actually land on chain, right?
We've got some comments. I don't want my orders getting involved with multiplexing users. If you store the order book in confidential data store and let the intent live for a few swab blocks, then settle the order book intermittently via batch auction, it'll be distributed. No.
It will be distributed as long as the confidential store is distributed. Right.
Yeah. I mean, I think this this really gets into what is the trade-off. Which trade-off on the distributed systems landscape do you want your order book to have? Like, I think multiplexing would be, I mean, that's just best effort. That's the L1 mempool right now. Just fire and forget. You could go further by doing some type of eventual consistency or like a Byzantine broadcast, such that actually, I don't know if that works. What you could basically do is require a certificate back from all of the TE nodes that you propagated to. Or you could just like straight up have a consensus protocol that ensures consistency. But again, that comes at the cost of speed, usually.
Yeah. So okay, we can solve this. We can solve this at the like storage layer, right? If you get some storage and it's distributed and like has whatever properties you want, right? For example, censorship resistance. Then by us simply providing you the storage service, you don't have to worry about anything else, right? I would guess.
By simply providing the storage service, you wouldn't have to worry about anything else. Yes. Correct. Yes, I think so.
Like save for like latency, right? Because your order will possibly be delayed. Okay, whatever. I think that works.
Big can of worms. But yeah, so for the scope of this, we're doing a singleton instance, no communication across nodes.
I think we don't have to stick to very simple use case. I think we can try. Let's see like if we had a magic wand, kind of like if we had a magic wand, what would we possibly want to have from this like T environment, right?
If I had a magic wand, I would have a Docker like YAML setup where I could specify a certain volume that is synced with another node, and encrypted as well. But that would be pretty hard because the container would need to have like access to new peers that join a peer-to-peer network, and like probably some type of DHT would need to be maintained. But that's super magic wand. I think service, which I think, yeah, storage service which handles peer connection and discovery would be like the much more realistic magic wand for now.
I kind of like this though. I'll show you how I think we could make this happen.
Okay.
All right. Okay. Let's build this up in a T, right? So your app is like ideally the UX is such that you just provided a container, right? Like there's of course like alternative solutions like WASM, stuff like that. Okay. Actually, before we begin, is this open source? Which part of it is open source? There's a bunch of code here, right? There's a bunch of code here. So the admin API can be open source. Dmarz servitor can be open source, right? So let's mark them as what's a good open source color?
Green, blue.
Well, I'm using green for like T.
Oh.
All right. Okay, so the order book is simple, validation is simple. They can be all open source.
I think basically everything but the engine service. I think the engine service could be also realistically be open sourced, but that would be the most understandable thing to keep closed source.
Yeah, I kind of know. I think okay. So the only concern with open sourcing this is that someone can abuse like some weird like it's difficult to have a perfect allocation rule, right? Or like a perfect solution. So people can try to, if they know exactly the code, you can try to craft like specifically to try to exploit like flaws in the logic, right? Some kind of wherever there's like heuristics, right? You can expect some kind of holes. So I don't know.
Right, which means the validation service also is potentially.
No, the validation I would actually keep open source because that's the part where it's better to have everyone look at it, right? Like avoid security by obscurity, rather just have everyone review it, right? And
well, so then why would the validations? Why? To me, it seems the same. Validation service and the engine service.
Oh yeah, because you know how to validate, right? You know how to validate stuff, right? You know exactly how to go and validate a order, whereas you don't actually know exactly how to provide the solution, right? Like there's no heuristics in the validation. It's very simple, right? Balance check, right? Nonce check, like whatever validity check, done, right? Whereas the solution engine will use a lot of heuristics where you can try to just abuse the heuristic. So match against the trade that there's another trade that's better, that would be better for the user, but because of the heuristic, you win, right?
Okay, but let's say, let's say I'm like trying to. Okay, so one of the big attacks, right, is I send an intent in, and I then pay the block builder a ton of money so that I remove my approved amount out and try to get in before this matched solution. Ideally, the settlement contract should like iterate through all of them and ignore. But I would think we would add some validation in that's like, okay, check if account has ever made a transaction, or like things like that, which would like try to make sidewall resistance just a tiny bit harder, which I don't think which I could find reasonable to not open source.
Yeah, I don't know. What does chat say about it?
Chat, how do we
What
stop
does
griefing?
Yeah, exactly. Okay, let's go
We can
with,
move on.
having those, having the validation. Okay. All right. So we have some stuff that we'll be keeping closed source, right? So, for whatever reason, and that will make this very difficult, right? Because if this was all open source, how this would look like is you could literally put it all into a T and call it a day, right? Like you're done. Like with everything open source, you simply attest. So check like what's running, check the image, check all the hashes of the binaries, right? And if all the code checks out and like the initial state of the VM that you're running matches the expected one, this is the process of attestation, let's say, then you're done because you know all the code. You can check that all the hashes of the binaries check out, and the state checks out. So you know that submitting your intents to the box will keep it safe, right? But if there's a closed source piece here, then you cannot do that, right? Like you don't want to reveal the source code, so you cannot prove to anyone that you don't do something funny here, right? That's the big difference.
Yeah, because I mean, you could leak that over the network at the validation.
For example, right? Just do whoop, right? And your data goes, somewhere, right? Yeah, not very secure.
It's super private, except for this one part where we swear we're not doing anything bad.
Exactly. So that's the tricky part. So let's try to rebuild this. Let's try to rebuild this in a T. So I want to have this for reference. All right. So we want a couple of things, right? So we thought about for a bit. What we want is we like a private key inside the T that only the T knows, right? That's important so that the signed batch. So when you submit a signed batch, only solutions valid according to whatever rules inside the T are ever submitted with your transaction, right? Nobody can switch the match, the solution, right? Your intent will only be matched according to the rules of the T. All right, and that only works if the private key that you approve lives inside the T. Right, so that's the first thing that we need. The second thing that we need is a way for users to encrypt their data, their intents, to a key that only the T knows. So kind of similar to this one, but there's a solution that you can readily use, namely the RATLS. So we don't have to, this will be like very custom, right? We'll have to like do this ourselves. This is kind of almost provided to us. Not quite, but almost. And then we want we want some data storage, and very importantly, it has to be persistent, and it has to be censorship resistant, which may or may not work, right? This may actually be impossible in like the simple case. Yeah, we'll for sure need like some kind of DA layer, maybe like a chain.
Yeah, I would say we should drop this requirement for this.
Yeah, but we can try. All right, and like one of the solution bits is that we want a YAML to specify like what kind of storage requirements we want, right? Some kind of configuration where we say that we want this to be synced wherever, or like we want this to be on live on IPFS, right, at all times, something like that. And we want some libraries for people to libraries. So yeah, libraries for verification. Right, so we want like a Node.js just a JS, I guess. Based on JS and Golang, of course. Am I forgetting about an important language here? Probably not. That's it. Yeah. So verification of the attestation should be possible in like normal code, right? By the client, ideally. And also ideally without like querying any other server, like but that's gonna be difficult. All right, how do we provide this? Like, let's say that we are building a framework, right, for TEs, which we may or may not be doing. How would we build an app like this?
Sorry, yeah, my emojis.
Got to preserve the emojis. Yeah, you know what? Can I group this? No.
Oh, I should have.
I can. Wait, no, this works. No,
Some people came for a T app session. This is actually a Excalidraw tutorial. We're sponsored. No, I'm just kidding. We're not sponsored by Excalidraw.
Yeah, although we probably should be this much.
If anyone knows Excalidraw people, please let them know.
All right. Okay, cool. So we want to have here a some kind of API server, right? It's open source, so we can just put it here and call it a day. This totally works. Put this in the background. Okay. We have an API server, and this is the simplest would be to just call it array_tls. Right. API server. And if you're curious about what array_tls stands for, again, go to the forum. There's links. There's in particular a link to the white paper on array_tls, or I guess just the paper. So it's a way for the users. Okay, let's put the front end here. How about? Because it's important. Oops, that's not how I spell front end. But we have a user, interacting with some front end, right? And the front end then goes and interacts with our array_tls API server, right? And this guy here has to be able to verify the attestation. So how this works is like this. So the user gives it like the expected measurement. This is the VM. Think of this as like VM image hash, firmware. A bunch of stuff like that. So this the user gets from somewhere, right? Like, let's say from GitHub. And then here we pipe in the array_tls certificate. Right, so the certificate that the frontend gets goes into this attestation verification box, and is returned A-OK, right? There's probably some like external service here, like if this like SGX decap, that's kind of it for something like cloud attestations. You have to go to the cloud provider and ask them if this is okay. Right. So this is for cloud proofs. We call this cloud proofs.
Which is for if your T is running in the cloud.
Yeah,
Quote unquote, cloud.
So this specifically TDX in the cloud.
And would you need to do that on every single expected measurement?
So if you're interacting with a specific front end, there's probably just one, or like maybe a couple expect measurements. Yeah, they come from somewhere. So, maybe it's a part of your front end, maybe it's a part of what the user knows and expects. Right. I'm not actually sure how to best structure this. All right. So here we get the EIP 712 intents, and we also get the certificate, right? And you have to attest. Okay, so I guess what was your question about whether we have to attest, whether we have to check the certificate every time we do something with the API?
Yes.
Maybe so the answer is kind of no, because this is you open up a TLS session. So if you think about like an HTTPS handshake, right? When you request the server like response, right? Response you send like a challenge, right? The server signs the challenge with their private key, right? That's exactly how it works. So by the end, you establish a TLS session, right? So you don't actually have to do this every time. You do this just once to establish the connection, and then every time you want to establish a new connection, I guess. But if your session times out or the box is started, you want to check it again. Yeah, and there's ways to get around this. Actually, you could possibly do this only once, but that would require us to do something custom here, and it's probably better to just go with RATLS. All right. Cool. So there's no admin API, but we need some kind of key service, right? Still, and the key service must be open source. And this, this generates the key, right? And yeah, so what has to be open source is that all of the pieces that touch the key have to be either open source, and then you verify that they don't leak the key, right? Or if they're closed source, like ideally you don't pass the key anywhere, you don't pass any confidential data into like closed source pieces. But if you do, then you have to somehow make sure that the data doesn't leak out, right? Let's talk in a second about how can you do that. Right, then we have the order book. I'm sorry, I guess we have the validation first. And the validation is the first tricky bit, right? Because it's actually cross source, right? We assume it's cross source, doesn't have to be, but for this exercise, let's assume it is. So how do we deal with this, right? So one of the solutions that we can propose here is just to have a firewall around the validation, right? Put it in jail, right? So this is some kind of either a subcontainer or like a sandbox binary. So this could be something like a WASM, right? That doesn't allow any access to, let's say, TCP, right? Or like files or any kind of devices on the host, so that you can prove that all that goes in. For every, like, you can verify what goes out of the box. That's kind of the important bit. So you specify what can leave the sandbox, right? If it's WASM, then that's simple because you just define the function API and you just don't allow access to anything, right? In the case of validation, what do we need for the validation? Right? And then let's think about it. So we need this chain state, right? That's I guess that's the problematic part. You need the chain state, and you need the intents, right? And you don't need all the chain states. And here it gets tricky. So let's assume we have a chain node. And it's open source. So we can actually make, I think we can actually make the sandbox request. We can flip the arrow, right? You can, because you can pipe in any data you want. The only problem is that the outputs can leak, right? So anytime the arrow goes this way, you kind of need an alarm bell going off. Does this leak data, right? Does this? So the validation would require, let's say, would want a balance of a particular account, right, or like a nonce, or which we suggested, which is have they ever interacted with anything, right? Something like that. Have they ever swapped on this swap, right? How many NFTs do they have? And I think as long as the chain node is open source, this doesn't ever leak any data, right? As long as you restrict only to specific calls, you can verify through the API on the chain node that this will not actually leak any data, apart from maybe for side channels, but let's not worry about those quite yet.
I think I agree.
Right. That's Andrew agree. All right. Anyway, and that's kind of the case with all the private pieces, where we have to put some kind of sandbox around it. Somehow we have to verify that the outputs don't leak any data anywhere, right? That there's only that we only allow specific outputs, right? That you cannot, for example, establish a TCP connection with someone, right? Or write a file on disk, right? Or like access a device on the host. So that's the job of the sandbox, and there's a couple of ways you can do it. One being, for example, WASM. Another being Solidity is a good one, right? MEVM, that's the original use case. And yeah, but also wrapping binaries through, for example, SID or bubble wrap. Those are like the binary containerization solutions, or by using a container sandbox, right? So for example, gvisor. It's like what you would use kind of in the cloud to separate guests from each other. And then you can define exactly what the container is allowed to do, right? You control the network interfaces that are passed in, you control the devices passed in, etc. You can simply disallow either of those. All right, that's a lot to say. That's a lot of words to say that this should be fine. And the other output is, validated intent, right? So there's two outputs here. One is like request to the chain node, which is weird to think of it as an output, but if you think about it, it kind of is an output. There's like data going out. The data specifies which address to go fetch the balance for, right, or which contract call to use to validate the intent. All right, and then this goes into the order book service, right? And then this also will be interesting. Because this order book needs a storage, right? And now this is gonna get interesting. How do we provide the storage to the order book service? Any ideas? Looking to source ideas. No, maybe.
Could you explain why, or could you explain the question again and why it's not obvious? Just allocate memory, bro.
All right, let's allocate some memory. So let's set the boundary of the T, right? This box is the boundary. And where does this storage live, right? So this is a VM basically. And it's like a T VM. And we already discussed about the need for the storage to be persistent, right? So we cannot actually store it in the VM, right, itself. We have to store it on either some kind of persistent storage outside of the VM, right? So let's write the options. So like, just disk, right? There's disk, there's memory. Right, and there could also be some other layers here, right? There could be some layers here, like ORAN, for example, to mask the access. Let's not worry about that. Let's see that we allocate some kind of disk space, right? And we allow the order book service to, like the database just simply lives on a persistent disk outside of the VM, right? Basically on the host. And my question is, would this work for this app, right? Is this enough? And my intuition is not really. Because it's very simple to wipe the data, right?
Right. You're saying it's easier to wipe memory though than disk. Is that correct?
I think they're both kind of trivial to wipe.
Okay.
Because as the host, so keep in mind this host here is untrusted, right?
Right.
This box outside is untrusted, so you have literally access to the device, to the block device, right? And you can simply just zero. You know exactly how much state there is and where it is, so we can simply assign zeros to all of it, right? So a simple solution here doesn't work. Okay, so how could we make so there's a disk, right? There's disk here, but we need some integrity guarantee, right? So that we don't just get erased. Because this, you can erase this disk even without the restart of the VM. Right. This is the important bit. So we need some kind of data integrity, right? And our order book service, the storage that we provide to the order book service, would write both to the disk and to some kind of data integrity layer. Let's say, it's a chain. We don't care if it's a chain or not. The important bit is that when we write something to the disk, we, let's say, write the we keep all the data in a microchip, right? And we post the hash, the root hash, to a chain, and then whenever we want to read from disk, we can check, right, against the chain. Right, and this would be better, right? Because then, as the T app, right, imagine that you're this order book service, you can notice that your disk has just been wiped, right? Because it doesn't right, doesn't match, the root hash doesn't match this what's on disk anymore, right?
Yeah, right. I think that's like super powerful. Could we just write down that point, like why? Because I think this showcases why blockchains complement the security of TEs.
And there's not really many things that can do this, right? Like if you don't want to use a chain, there's only really so many things that you can use, and they all will involve some kind of consensus, right? So it might as well have been a chain.
Exactly. It's sort of like security by committee over the data storage.
Yeah. And then you can also verify, right, that the committee does what they're supposed to do. Another way would be, of course, to use something like, just don't store data on disk, store everything in some kind of DHT, right? I've already mentioned. Right, so there's some solutions to storage, and the problem with this one, the problem with using just the chain for data integrity, is that it doesn't by itself necessarily shield you from restarts. Right, when your disk gets wiped and then you get a restart, you lose all the memory. You don't actually know like necessarily where to look for for this integrity, right? So it has to be tied to like a specific app. Right, not even just in a running instance, but like we would want to have this data integrity or this DHT. Be also aware of the specific I don't know set of instances of the app or like in general the app, right? And want to tie this data integrity, this checkpoint to the app, so that when the app starts, it doesn't assume it started from scratch. It can actually verify, have I just been restarted, right? And if I have, I need to go pull my data, right, from somewhere. It's also very important. All right. So that's for the storage. Simple case is you just mount a disk, right, and then you encrypt the disk with some key, right? That's the simple solution, but it doesn't shield you from the host. You can use some kind of data integrity outside the trusted host. So let's say on a chain, right? Some kind of censorship resistant layer that you can access, or you can at least know that you cannot access. In which case, you should refuse to start. Right? If your untrusted host blocks this arrow here, it doesn't allow you to access data integrity. You should simply refuse to start the app. Right? That's also important. And if you want to distribute the data, right, you can always use some kind of DHT, but it doesn't necessarily help you with integrity by itself. All right. Let's just call this encrypted data. Because it's very important that the T controls the encryption here. And here is some checkpoints. This is against thing they're called replay attacks. And this is data distribution. Right, so those are the like we can already provide you free things as kind of a T like a framework, a T framework. Another thing is this sandbox, right? Like a T framework will need this kind of sandbox where if you want to run some private code, you need a way to sandbox it properly. And there's this very standard, I think, requirement that you need a private key. All right, so that's already free. Things that we should be providing you. And I guess they're ATLs. All right. What's left here? The engine service. And the engine service will be very similar to the validation. Right, so I have the smashing engine here. And again, now we have to think about the sandbox, right? What does it get? What does it not get? So it gets the chain state. And again, because the chain state, the node is open source, we can simply request the state. Which isn't always the case, by the way. Like this is not always the case that you can request something from outside. For example, in the case of SGX, this actually is very tricky. And this works very nicely in TDX, but in SGX, this would require the chain node to also be in SGX, and yeah, actually that's not even that's not enough. So yeah, this is not straightforward. But if you run into trouble, you can always just flip the arrow here and only pipe the chain state in, right? And just maintain the state inside the sandbox. It just increases the requirements on like memory. All right, and you can get the orders here. And then the last bit, so this outputs matched intents. Okay, and because this is code source, we cannot actually verify that this match is valid, right? Also important to note. So we can't actually just push this batch submitter, right? We have to have batch validation, right?
And okay, what does the batch validation do?
What does the batch validation do? It will look at the matched intents and check that it's indeed matched.
Okay, so it's just like a sanity check.
So this is where it becomes tricky, right? If you don't know how you've been matched, how can you be sure that you've been matched correctly?
If you don't know how you've been matched, how can you be sure you've been matched correctly? Well, I think all you care about is that your invariant is satisfied. Oh, sorry. Wait, did I say invariant? I forgot the cool kids are using the word intent.
No, this is the event, like intent.
No, it's invariant.
Yeah, invariant check. I think that's right. But can we do more? Can we do better? Because this is not because this is really what the guarantee to the user will be, right? The guarantee to the user will be exactly how well you can check that they were matched, right? Can you check that there's no better? Can you check that there's no better candidate for a match in the open source code?
I don't think it's possible in a privacy-preserving way.
But we can access the order book, right?
But then we would need to get all valid bids and basically just recompute the optimal bid, which would just be recreating the matching engine, right?
Sometimes it's easier to verify than to solve. I'm not sure if this is one of those cases. Like you can verify quickly, of course, and that it does indeed, that the solution does work. Can you verify if it can be better? Probably not. You're probably right. But we can at least show that it does at least as good as X, right?
Okay. Yes, I will say, yeah, so the one thing, yeah, so I mean, we get into the cow swap thing though, where the problem there where you can only verify top of the block. You know?
Yeah, and this is here is the case as well.
Yeah. But okay, that's fine. That's fine.
Yeah, I think that is fine. Like if you had the direct line of communication with the builder, you could actually pipe in partial blocks, right? And also make sure that the same is true outside of the top of block, right? So it's not, I think, a limitation of the app, it's a limitation of how closely are you integrated with the builder. All right. So we have the patch validation, and I think it should be checking something. So at least it has to check the invariance, right? At least it has to check that the solution does satisfy the intent, right? So that, because if it doesn't, then you can simply send those solutions to the builder, have them revert, and then you know the intent, right? So we want to, right, and because of this, we want the key to go here. Goes like this. All right, I think that's it. I think that's all you need. All right, so what does the user get? Like if you build this super complex app, right? What does the user get concretely?
What does the user get? The user has a service they can interact with to facilitate the private swapping of assets in a manner that is verifiable from both the front end code introspection and runtime, maybe.
All right. Yeah, I think that's right because and again, like the quality of the solution is only as good as we can verify in the open source part, right? This is kind of important. Like we cannot say that they get the best possible batch, right? That they get the best possible solution. But we can say that it will, have pre-trade privacy, right? That they will be matched. Actually, can we? We can't say that they will be matched, right? Because the matching engine could also just refuse to match anything. But we can say that they will be either matched or not matched, and their or the intent will simply go invalid, right?
Yes.
They will never be matched incorrectly. All right, I think that's kind of it. And there's one arrow missing here, which is the pub key to approve. Oops. Yeah, so when we generate the key, that we need to have like this has to go through the RTLS server. All right. All right. So the pub key has to go through the RTLS service because that's where the TLS session is, and the user has already validated that the session is valid, right? They check the attestations. So if if the API will only allow the correct pub key to be sent to them, then it's enough for them to request the key from the RTLS. They don't have to actually check any attestation again, right? We could provide a separate attestation report with this public key embedded, but we don't actually have to. We can simply reuse the RTLS API. That's why it's nice, right? We don't have to like do anything extra. We just generate the key and return it from the API, and we're done. Which is very nice. All right. I think that's it. That's the service. If you want to put in a T, that's it. I think you could now worry about who provides this code to validation for validation and matching, and how exactly to solve this. But at least we know what we want. So just to reiterate what we want to provide, the service like this. Right. So if you're building a service, it would be really nice if you provided the following. All right, a service to generate keys. Right. this will be very similar to the MEVM, right? Because it solves the same problem, of course. So easy to integrate. Right, we want like a easy to integrate array TLS server. Maybe the server is just a thin layer. Oh no, no. Don't remove everything.
No, I'm just copying it. Sorry.
Okay. So the array TLS server could actually be like a layer before the actual app service. It can be HTTP. Right, so this array TLS server will simply proxy. So we can just call it array TLS proxy. And yeah, that will proxy the intents. Yeah, so that every request that goes through this proxy will be forwarded to the app API server, unless it's a request of of a random generated key that needs to go through the attestation that you can't actually. I guess you could do it through the app server too. I guess either works. Yeah, something like this. Because we have thought about a couple of apps like this, and almost always they need some kind of key that has to be approved. Right. So next up we have like a storage solution, right? Persistent storage, integrity preserving. Optionally with sensor resistance, right? Like distributed sensor resistance. Because this reviews the part and like both actually will add a lot of latency. Integrity also adds a lot of latency, but on the other hand, without the integrity of the data storage, it's kind of useless. Like you can't really rely on the data, right? As long as it goes to disk. If it goes to memory, it's different, because if it goes to the memory, it's not persistent, but it actually is integrity preserving, which is nice, right? So for the memory, we don't actually have to provide anything specific. There's like asterisks with page tables, but it's not that bad. Like with the disk, it's really that just doesn't work. All right. And the sandboxing, right? Sandboxing. Yeah, because some code you don't want to be public for whatever reason, and yeah, even here you kind of want some of it to remain private, or at least like parts of it to remain private. All right. So this is what we'll get, right? So if we are going to provide some kind of framework for building T apps, I think that all of those should be part of it. Okay, let me pause for questions. This was a long streak, so I'll pause for comments and questions. Yeah, dmarz, what do you think about it?
There's a bunch of questions comments from Andrew in the YouTube channel. I don't know if Andrew, if you wanted to comment on these.
I mean, they just streamed in overtime. Yeah, I agree with everything, how it ended up.
All right, let's go.
I think here, I'll post these.
I think this chain node will either be using an ORAM or of all the L1 states streamed in, or have to store the whole L1 state in RAM. Or on economic queries requiring a subset of state in RAM. Yeah, absolutely. I absolutely agree. And I think that the simple thing that we can do is provide an ORAM layer here, right? So that's, or rather here, right? Right, this will be like integrity preserving by itself and have a bunch of other properties. And the same for the chain node, right? The chain node also needs disk access, and same applies, right? In persistent storage, that has like some integrity built in. Yeah, to connect the local VM disk with the enclaves view. Yeah, exactly. I think that the solution where you put it on disk, but you have like separate integrity checkpoint somewhere. Okay, next one is for proprietary code. The matching engine is private, but at least this one is easy to verify that it satisfies the invariance. And this is very important because, and I was kind of trying to stress this, the only guarantee that we give the user is what they can actually verify in the code, right? So the only guarantee that we give to the user as for the quality of the solutions is in this batch validation rather in this matching engine. So here it's actually kind of simple to do, but that's not always the case, right? Sometimes the case will be that it's not easy to verify what this closed source piece outputs. In which case, it will be much more difficult to do it correctly.
Is it right that the validation, I don't understand why the validation, what's meant by that still being, is the validations proprietary as well?
The validation can be proprietary, because it's actually not, like the validation being closed source doesn't give the user any worse guarantees, right? It's only there to protect the operator.
Yeah, exactly. You could imagine it, the validation service being like a cat and mouse game.
Yeah.
And it doesn't matter to the user because wouldn't I want some kind of proof that, I don't know, my transaction succeeds? Yeah, I'm not sure what to expect there.
Yeah, there's probably a bunch here because you could, the operator could put like code in there to filter out certain addresses, which like wouldn't be great. I think the idea was basically like you could imagine the service wanting to block like, you know, random constraints like, oh, accounts that have never transacted before are probably DOS is one example. And like a whole host of things like this you could use to try and detect a person. But I agree, it also does open up room for censoring the user.
Absolutely. And ideally it is open source, right? There's like you can also have like both. You can also have like an open source part where it checks, you know, the balance and nonce, and then a closed source part that does like post checks, but cannot do anything else but to like approve or disallow.
For some reason, this reminds me of like GANs, like general, is it adversarial neural networks, where it's like we have a private source code and then an open source, and like the private source need to convince the open source part that it's not doing something like wrong, even though it does still have some secrets.
Yeah, absolutely. And I wanted to touch on one thing that Andrews mentioned, which is that this matching engine could actually provide, in some cases, proof of optimality somehow, right? You can actually like compute proofs, like zero knowledge proofs or full knowledge proofs, I guess, to convince the open source, exactly as you're saying, to convince the open source that is an optimal batch to not just a batch, but an optimal solution, at least according to some logic, right? You can have proofs coming out of the private code. Yeah. All right, sweet. Any other comments?
I'd love to dig a little into exclusiveness. Like, this came up when you mentioned the possibility of having the order book or something be distributed. And I wonder if it's just clear from this whether this probably matters a lot or doesn't matter. But it seems like if the other people bidding are also multiplexing to other instances of a similar application, won't it be more likely that they'll somehow conflict with each other? Which that is really nice if you can guarantee that won't happen.
I think, yeah, that's like almost guaranteed to happen if there's singleton instances of these that aren't communicating.
Yeah, absolutely.
I mean, the intent will fail, so it's not really that bad. It's probably bad for the operator because there'll just be some gas usage, but two of the same intent can't be satisfied. So that's like not awful for the user.
So I guess it just wasted compute if this ends up being done a lot redundantly, and then maybe that's all that's at stake.
Yeah, and possibly also some reverts. You could lose some money, and if you have been a part of a batch that didn't land, and you have not been a part of the other batches, your intent will actually be revealed, right? So you want some kind of guarantee from the builder that at least they will not include the failed solutions. Yeah. All right, cool. Now the question is, how do we actually provide this, right? We have, okay, yeah, Ferran and Mo, do you have any questions maybe?
Not from my side.
Nothing from my side.
All right. In that case, the next part I think is, how do we actually provide this, right? How does this technically look like, right? So this is a VM, and so the initial idea, and this is what dmarz already said, some kind of Docker library, Docker compose, set of containers, right? Because we are mixing here like private code and public code, and we need to be able to attest the public code. We can't actually provide all of it as a single piece, right? We actually have to go and split them, or either split them like in general, or have only the open source parts in one chunk, but then load the private parts, right? Like we can't provide all of it at once. And the already existing, one of the already existing solutions is just the Docker Compose format, or Kubernetes-like YAML, some kind of definition like that, where all of those pieces are simply containers, right? That would probably be the nicest UX we can go for.
Hey, Mateusz, by the way, we can't see yours. I think your screen is either frozen or...
Oh, sorry. Yeah, I'm not yet doing anything, but...
Oh, cool.
Yeah, initial idea is to provide all the pieces here. I think you can see it now, right?
Yes. I can see it.
All right, let's go. So all those boxes could be containers, right? And also the cost source parts. And I think that's like the intuition would suggest that this is a way to preserve the UX that people are used to. And it does compose nicely with like our optional services that we can provide, right? Like the the key service. Right, in storage. There's already built-in, like the format is very well known and understood how you mount storage, right, and how you request specific kinds of storage. So you can reuse the format very nicely. And I think that's it really. And then, yeah, we go and run those, we have a, okay, how do we run this? So we get a bunch of containers from the users, right? Like dmarz, you go and build all of those containers, right? You put them into like a YAML or like a compose file. And what do we do with that? Right, now's the question. Yeah, well done. Okay, so let's think about it for a sec. What are the ideas? How can we, we get a set of containers, right? How do we go and run it?
We have a set of containers.
So one way to do it. Mm-hmm.
Oh no, I was going to say. I mean, this is quite a complicated. If these are all containers, then it's a pretty complicated setup. We need some type of like container orchestration.
It doesn't orchestration. Right, so we need an orchestrator, basically. Okay, we need both an orchestrator and a hypervisor. Right, or a supervisor, like whichever you want to call it.
Mateusz, are you saying this is like a split between a template and like an application specified thing? Like I'm wondering if you're imagining a Docker compose just for defining somehow the proprietary red bits and all of the other things in the VM are, I don't know, part of a higher level already provided template, everything else in the container system.
Yeah, I think of all of those boxes here as provided in this. Yeah, I guess you can call it a template, and then you specify the red boxes and the custom, you specify which boxes you want, right? Like this key service we know, and this RTLS proxy we know. But you give us, the patch validation, the submitter, and the matching engine, right, and the validator, and specify that the matching engine and the validator should actually be sandboxed, right? And then there goes the definition of the sandbox, right? This is how you want it sandboxed. Maybe hopefully that's clear, and hopefully it works because I can be clear about speaking nonsense, of course. But yeah. Anyway, so this set of containers, right? And configuration, right? Or like a template is sent to some kind of orchestrator. It's actually both a orchestrator and a hypervisor, and also it also works in the T, right? So that's the important bit. That's how I can see this working. Oops. So this is the T VM is now slightly bigger, and orchestrator and the hypervisor actually run inside the T, right? And they will go and run those boxes for you. Right, that's how I can see this. And if you think about it, this should work, including the sandboxes, right? Because we have the hypervisor here. We can define the rules for how each of those containers, what devices do they have access to, right? Can they establish connections? We have the firewalls, the IP tables, right? So we can do some fine-grained network sandboxing too, and not just prevent anything from leaking out, but have slightly more detailed control. And I think that's kind of it, right? And then the orchestration can just go and run all those containers as specified. And this is kind of a soft, like we know how to do this, right? We have explored the running like Docker images and like Podman and some other containerization inside TDX in particular. So we know that we can do this in practice. And yeah, and we would be providing you all of the services that you'd want. So the standard services, like your app wants a key, right? And a key that only this TDX or this T has access to, we'll provide that to you, right? You can just say in your Docker Compose that you want our key management container to run, right? And we'll make sure that it runs for you, right? Or that you want like a node, right? Right, those are the kind of standard building blocks. Yeah, so dmarz, if as a part of your app development, you are supposed to give us or give me a Docker Compose file and those services that are app specific, so the API server, the batch validation, the order book service, and validation and matching, and define the connections between those containers, right? Which container writes to which container and how they do it. Would that be fine for you, right? Would that be like a decent UX?
I think that would be a great UX, yeah.
All right.
I mean, that sort of mirrors what I need to do today, right? When I have a sort of a complex set of services that need to be deployed.
Right. I think that would be ideal, right? If we can make this work. So there's actually a couple of issues here. We need to pass the private code has to be passed in trustlessly, right? You don't want to push your private container into Docker Hub, right?
Right.
So we need some way to encrypt the containers in such a way that only the orchestrator can, decrypt them. That's one thing. And this will be the fun part. We need transit attestations. We need attestations such that this RATLS proxy, when it passes the attestation, right, you can actually verify not only the top level TEVM, which is the orchestrator, but also all the containers that run, right? And give me a sec. And this is actually not trivial. It does work. You can get the containers inside a TEVM. So those little boxes, they have access to attestations, right? You can actually produce attestation reports from those, but it's not trivial to show that the attestation that they get is enough for you. So there's some we need to go and like research this somewhere. What other issues do we see here?
I mean, there's always the question of performance. So how performant is this?
Yeah. So this is tricky. So we can use nested VMs, right? And the containers inside the TVM should actually be relatively performant, especially if we enable KVM support inside, and we could in theory. I'm not sure if we can allow like hardware, like access to the KVM module. I'm not sure if you can. I'm not sure if we can provide access to the KVM module from the private code. So can we accelerate, do hardware acceleration of the private code? Because we are giving access to like a raw device, right? And we don't know what the people are going to do with it. So it could be unsafe. I'm not actually sure. Yeah, hopefully we can. Well, but the open source ones should actually be like very performant, especially in TDX, right? If you're talking about SGX instead of TDX, then those of course cannot be containers. They have to be like either WASM or like EVM contracts, right? Something like that, rather than like full-on containers, which of course the UX is worse, but it should still kind of work. Yeah, there will be like huge issues with the chain nodes, of course, with SGX because they're huge and it's very difficult to run them.
Yes.
All right, so that's just some questions. It's of course not all of it. Yeah, and like who controls the orchestrator, right? How do we make sure that all of the containers run? Right. I don't think it's trivial. Hopefully it is, but right, lots of questions still here. But yeah, TX would be nice. And we're almost at an end, so I'll pause. And yeah. Any questions?
Only question for me, next session, are we coding it?
Hopefully. Hopefully you code the app and we already have the framework, but yeah, this will take some time to build.
Okay.
But
I mean, technically we are doing it right now. So yeah.
we are doing it. Most built alpha. Yeah. We are working on
we're not building a dark pool, is just to clarify.
No.
Yes, okay. I mean, let's
Yeah.
code the dark pool part. If anyone is listening to this and wants to provide a dark pool code base based on this that we can use, please let us know.
Absolutely. And we are building bits and parts and bits of this solution already, right? We have some other products that we built very specific things for, like this, this TLS proxy, right? We are building it for like a different product, and the key service we of course have made for the original MEVM, right? So we have bits and pieces here and there, but connecting them will take some time. All right. Okay, I think that's it. So Fred, I'm not sure. Do you want to take over?
Yes. Can you guys hear me? I had to recharge my headphones. Cool. Awesome. Thank you guys so much. This was very interesting. This was the 5th session on Flashwares. We're planning many more, so keep an eye on the forum, collective.flashbots.net. And if you're logged in at the forum, you're able to watch this tag and be notified whenever there's new posts and new sessions planned. So thank you all so much.